Thank you, sir. Very good evening to all dignitaries, participants, coordinator and convener of this FDP. I conclude to Dr. Rajesh Arya sir to organize nicely this FDP, and I thanks to the coordinator of this FDP, Dr. Rajesh Arya, for inviting me as an expert talk of this FDP. I share to.
Thank you, sir. Thank you.
Visual, sir?
Yes, sir.
Yes, sir. Visible.
PPT. Thanks.
It is not full screen yet.
Not full screen. Okay. Just 1 minute, sir.
Yes, yes, please.
Okay. Now visual full screen, sir.
No, sir, not full screen.
I think you are sharing wrong window.
Just 1 minute, sir. Again. Now sharing full screen, sir.
Yes, yes. Now it is.
Thank you, sir. Firstly,
Yes, visible. Visible.
visual.
Yes.
I would like to discuss the optimal design and energy management of isolated integrated renewable energy system for rural areas. I would like to discuss the following contents: introduction, classification of sources, system description, hybrid energy system model, novel energy management scheme, and result and discussions with and without demand response sensitivity conclusions. Then introduction, the scarcity of conventional energy resources, rise in the fuel price and concern for the environment from the burning of fossil fuels has made power generation from conventional energy resources unsustainable and unviable. The use of fossil fuels, coal, gas, natural gas, meet the heat and energy need of quite often domestic, commercial, agriculture, industrial applications. The availability of coal, oil, natural gas in the earth is limited. The system's socio-economical and environmental point of views, exploitation of renewable energy resources provides sustainable and viable of opinion local solution and provide the job opportunity use of this renewable energy. our India is the developing country. Most of the populations lives in isolated, unelectrified rural area, and extension of the grid power to the remote place is quite complex and expensive. The electrification of these area is decentralized, made by the nearby available renewable energy resources will benefited overall development of these area. Utilization of oil, coal, oil, these fuel provide the several environmental problems such as atmospheric, such as greenhouse effect, temperature rise in earth, sea level rise, floods, heat waves. These are many problems created in the use of the fossil fuels, oils, coal, gas, etc. These uses. Basically, have the two types of basically in energy sources: renewable and non-renewable, conventional. Conventional energy sources like a fossil fuels, coal, oil, natural gas, and nuclear energy. These are the limited resources in the earth. But non-conventional energy sources are renewable energy sources is unlimited sources. Solar hydropower, solar, small hydropower, biomass energy, wind energy. Solar is the very large amount of available in the earth. Our geothermal energy, tidal energy, ocean waste, and ocean thermal energy. Worldwide energy scenario of electricity. This worldwide, this pie chart is indicate the scenario of the world in which type of fuels are used. But in this is mostly 5.70% used in the coal. Basically, depending on the coal, oil is 2.73%, natural gases 22.28%, biofuel 2.193%, waste materials use 93. This pie chart is basically indicate the whole world energy depending on more largely is fossil fuels, but increase the nowadays the solar non-conventional energy sources. Solar is 4.33 and wind is 7.24%. This in the Indian scenario of energy, coal is 46% contribute in coal, lignite 1.45%, gases 5.3%, diesel 0.13%, nuclear 1.79%, hydro 10.28%, and renewable energy sources 34.71%. This data is a Central Ministry of Electricity Ministry data. This data mostly this is nowadays renewable energy sources are day by day is increases. Initially in past mostly depend on the fossil fuels, coal and hydro these, but nowadays 34.71 contribute the renewable energy sources. This is the renewable energy sources in India. Up to data is 30 November. See, data is this. Small hydropower contribute the 3.21%. Wind power contribute 30% approximately. Biopower 7.13%. Solar is mostly largely approximately 60% or 59.39%. Renewable is large amount of this is 59 is 60% total capacity is this. Key feature of the India population is this. Total area of India is 3.28 million kilometer square. Energy is available in India: coal, oil, gas, nuclear, hydro, rest solar, rest of energy. Electricity consumption is 144.25 billion units. Electricity generation is electricity generation capacity is 442 gigawatt. Per capita consumption is 1,395 kilowatt. This is indicate the per capita consumption indicate the means individual per person how much electricity is consumed in 1 year. This overall network losses is 21% or 5%. This data is from Power Ministry of Authority, India. Yes. Installation capacity of the renewable energy sources day by day is increases, but mostly of the solar power generation is installation is day by day. Now this is day by day increase, and 24 is this data. Growth of energy generations. This day by day energy generation is also increased, and this is least negative generation means minus 0.5 corona during the corona period 20 to 21. Other time is energy generation is increased day by day. This is the methodology of this is site selections. So site selection is basically in government Rakiya Engineering College Banda is site selections, and demand assessment. Demand assessment is demand assessment 3 hostel in our college and 1 STP plant. Resource assessment is PV, solar PV and diesel generators. Constant variance next discuss. Selection approaches, modeling and various selection approaches use the Umer software for this is modeling of the various component Umer software, and it lies the sizing, cost optimization, operation control and consideration, system configuration. First is step identification of area. Firstly, identify the our institute Rakiya Engineering College Banda for survey and investigate the load demand assessment. Hourly energy demand is estimated by considering various load which can be used in 3 hostel and 1 STP in our institute. This study is implemented in our college institute. Resource assessment, estimate potential resource assessment, solar, PV solar, DG and grid. Basically 3 parts in this study. Constant and various like as a generation demand, balance, individual capacity, reliability parameter. These are the constant various. PV generation is maximum 0 to maximum generation of PV set. DG set barrier limit is 0 to DG maximum rated DG. Grid cell power is cell to grid either purchase grid how much power is maximum cell grid is also limited 0 to minimum 0 power is cell and maximum grid is also defined, and grid purchase is also the maximum. These are the barrier are constant in our study. Modeling, develop a mathematical model of consider configuration and Homer software, unit sizing and cost optimization, optimize and control the selected system configuration with suitable technique, Homer software. System description. The solar or DG based system along with grid has been considered and modeled to supply energy in the 3 voyage hostel and 1 STP of Technical Institution Rakiya Engineering College Banda located in Uttar Pradesh, India. This location is situated at longitude of 25.28 degrees north and the longitude 80.58 degree east. The excess energy is sold to grid whenever generation of PV and DG exceed the demand, whereas the defeat power is purchased from the grid in case of generation from sources less than the required demand. This system layout, this is our experimented system. One DG set, solar system, photovoltaic solar system, grid is bidirectional, power sold or purchased both, and this DC bus, solar PV generated to DC, then bidirectional converter DC to AC, this, and load is AC, our load is AC. In case power generation load demand is high to PV generation and solar PV system, then purchase the electricity purchased from grid. Otherwise, demand is less than to solar PV generation and diesel, then power sell to grid. This is basic system. These are the solar PV array model, PV generation. PV output is the PV rated derating factor into solar radiation upon 1000 into 1 plus delta temperature coefficient into T cell temperature in PV, and cell standard temperature is 25 degree centigrade taken in our system. This is the solar power output. Solar power output at depending on these factors, derating factor, solar radiations, temperature coefficient, and temperature radiation base factor. DG model, DG fuel consumptions, DG QT is fuel consumption equal to DG PDG alpha DG PDG plus beta DG into DG rated power of DG diesel output. Alpha and beta is the coefficient of DG. Depending on these values taken, alpha DG is liter 0.24 per kilowatt and beta DG is 0.018145 per kilowatt hour. This model, this equation utilizes the fuel consumption, equation number 2, and equation number 1 is utilized for the PV output power gen. This is electrical grid modeling. In case grid P is the purchase. In case load demand is greater than to generation, PV generation and DG, then purchase to grid. So amount of grid purchase equal to P demand minus PV output of PV cell, eta C is the converter efficiency, and DG power. And in case demand is less and generation is more, then power supply to sell the power to grid. So how much amount of electricity sell to grid? So by utilizing this equation 4 to sell to grid, so P grid sell power sell to grid equal to power output of PV into converter efficiency, inverter efficiency plus DG output power minus demand. These equation, these 3 and 4 equation utilized to how much amount of power sent to grid, yeah, either purchased to grid or sell to grid. System economic model. This is the total system net present cost, total system, and TSNPC, total system net present cost equal to system annual cost upon capital recovery factor. These are the system annual cost is the sum of the annual cost of PV cell, annual cost of DG, annual cost of purchase to grid, annual cost of converter, and annual cost of diesel. These are the total annual cost, and capital recovery factor is depending on the rate of interest and these other factors. This is the total system net price present cost. This is load model. Basically, you have the demand response. A rule-based novel demand response scheme is proposed for performance enhancement of hybrid system. Hybrid grid and solar DG, how to perform manage this system. So first is load categorization. Load are divided in two categories. First is priority load and second is shiftable load. Priority load is need to be made out as per consumer use, whereas shiftable load can be shifted in the different time slot as per the user need. Priority load in such as in our study, tube light, ceiling fan, refrigerator, insect killer, drinking water, exhaust fan. These are the priority load. These are the cannot be shift to any time. But shiftable load is a water geyser, blower, submersible pump. In our study taken that these are the shiftable. Shiftable means a time slot is this time slot is any time is operate of this system. Applies next. The operating range of time slot of shiftable appliances is described by the consumer and denoted by the binary variable RT1. At any time, if represent the 1, specify the switch on, otherwise represent the 0 is the switch is off. Shiftable load. Daily hour of the shiftable appliances are also required. After calculating average demand and hourly demand, all shiftable appliances have been allotted in the user defined time interval. In case when hourly demand consumed more than the average power consumption, shiftable appliances is shifted into other time period in the user defined range of interval. This practice is repeated for all shiftable appliances in order to minimize the peak demand. Peak demand is minimize shiftable load. In shiftable load in this study, our study, in name of shiftable load, blower of STP, this study in our Rakiya Engineering College, Banda, 3 hostel and 1 STP. STP plant, user defined range of time in any time 0 to 24 hours. User defined in whole day anytime. A daily operating hour is 20 hours. Number of appliances is 1. First is for submersible pump, whole day range, user defined any time of operating, but daily operating is hour 10 hours. 1. Second, submersible pump. This is also user defined is whole any time is 0 to 24 hours, any time bounded, not a case, but daily operating is 10 hours 1 day. But geyser, water geyser in hostels required in morning 5 to 8 hours, user defined, and evening 5 p.m. to 7 p.m. 3 hours in daily, and total number of appliances is water geyser is 48. This case study in our studio. This demand, shiftable demand this is electricity demand equal to ED is the shiftable electricity demand, EPD is the priority demand, total electricity demand equal to priority demand plus the shiftable demand. Shiftable demand is dependent, utilize this formula ESD, shiftable demand plus binary digits 0 to 1 and binary variable 0 to 24 hour, which time is on the switch, this, and total shiftable BSD binary digit plus binary variable sum of is 1. This utilize the equation number 7 to electricity manage the demand, energy demand. By data analysis, first Homer software, by using the Homer software, provide the base simulation of hybrid system in solar system, DG and grid. Many input of such is solar radiation, wind speed, hourly electrical energy demand, thermal demand, also economic data of each component such as a capital cost, maintenance cost, replacement cost, also required before simulation. And after simulation, make the several combination of component based on inserted data, and these data are combined the order optimize and cost fulfill the upper desired. This is the month-wise ability of the solar radiation. This is the solar radiation is our location. Solar radiation is maximum is May 7.05 kilowatt hour per meter square. This is month-wise January, February, March, April, May, June, July, August, September. This graph is so the maximum generation is May and minimum generation of December for radiation, solar radiation 4.08 kilowatt hour per meter. But the annual average radiation is estimated, this study 5.26 kilowatt per meter square per day. And diesel price is also taken $1.187 per liter. And grid purchase and grid sell value is like $0.121 per kilowatt hour. This is the efficiency curve of DG generator. Efficiency is increased when the output power is generation. This is efficiency curve. Load profile of the with and without summer seasons. Load profile summer season with DR, and this is yellow, green is without DR and with DR. Demand response and without, this is hourly in whole day, this summer season, and this graph is so the winter season of. Economic data of system component in our study, name of system, PV system, converter and DG. Rate of capital cost $513 per kilowatt. Replacement is also same cost, PV system, and rate of maintenance cost $11 per year. Converter cost, converter component, basically three component in our system. Initial slide is this PV system, converter and DG. Converter cost rate $40 per kilowatt, and also in case of the replace converter, same cost is $40 per kilowatt. Rate of maintenance cost $1 per year. DG cost 570 kilowatt per dollar, and replacement cost is 540 per kilowatt. This is the data is taken and calculate the final result analysis with and without demand response, how affect this system. Without demand response schemes. This is PV array 3, 180 kilowatt, 180 these tables. This is indicate the cost of generation. Cost of generation is or the cost TNPC and system annual cost, and cost of generation is this table is so the of this generation and purchase grid cost, etc. And next slide is also compared to with and without demand response and with demand response. With demand response, this is total net present cost, this system, and cost of generation. Annual cost is total cost of generation is 0.127 kilowatt hour with demand response. Without demand response is 0.13. By using the demand response is less amount of the cost of generation as compared to this. Comparison with and without DR in many factors. This total net present cost unit without demand response is 5,09,263, and with demand response is this. The reduction amount is 25,600. Total annual cost of system in dollar without demand response is $39,838, and with demand response is $37,835. But reduction is by using the demand response $2,003. Cost of energy generation per without demand response 0.133 kilowatt per dollar per kilowatt, and with demand response 0.127 per kilowatt. Reduction is 0.006 kilowatt per dollar. Operating cost is also this table study. Operating cost without demand response is 30,193, and with demand response is 28,546. Reduce this cost. Initial capital cost is also reduced $4,560. Replacement cost is also reduced $635. Fuel cost is also reduced 24,215. Size of DG is also reduced with demand without demand response 40 kilowatt DG size used, but with demand response only 36 kilowatt size DG is used, and 8 kilowatt DG size is reduced. Grid sale of electricity without demand response is 209. This is the negative part. Sell most of the electricity is consumed. Grid purchase electricity. Peak demand is also reduced. Without demand response is 89.90 kilowatt is peak demand, and with demand 83.46, and peak demand winter or summer is also. This data is utilized and shows by utilize the demand response, manage peak demand manage, then overall net present cost, annual cost, generation, operating, initial, replacement, all factors are reduced this. Sensitivity analysis. A sensitivity analysis of the proposed hybrid system has been investigated. System parameters such as a capital cost of PV array, grid purchase price, diesel price, interest rate, and solar radiation have been varied from -15% to +15% of base value. The effect of parameter variation on cost of generation have been determined. The cost of generation is deviated from $0.148 per kilowatt to $0.0108 per kilowatt for annual average solar radiation, changing from 4.471 kilowatt per meter square to 6.049 kilowatt hour per meter square. This is the sensitivity.
Please unmute. Pushpendra, please unmute. We are not able to hear you. Yes, now you can talk.
Just 1 minute, sir.
Yes, no problem.
Due to net connectivity. Just 1 minute. Is slide slow, full slide slow, sir?
Not full screen.
Not full. Just 1 minute. Sir, so full screen, sir.
No, sir, no.
What problems?
Hello, Pushpendra sir.
Yes, sir.
Sir, at the bottom there is a switch na nearby 64%. You can just click on that
You can
at the
share.
bottom. At the bottom there is a 64% na, right? There is a sign of cup. You can click on that.
You can share, sir.
I do not have the right PPT, but at the bottom you can click, sir.
Not share, sir. My problem. Something.
Okay. Just
Something. My.
Let me try to share. Just wait, sir. I think now it is full screen.
Yes, sir. Last slide, sir. Conclusion. This. Okay, sir. Yes. Conclusion last. This study, audible, sir?
Yes,
Audible?
you are audible. You are audible.
Okay, sir. Finally, conclude this study. We found the total system, net present cost, system annual cost, and cost of generation are reduced with the DR scheme applied as compared to hybrid system without consideration of DR hybrid system. Net decrease of dollar is total system net present cost, system annual cost, cost of generation is reduced of these value is with DR, and also DR scheme reduce the DG size to 36 kilowatt to as compared to DG 44